Hello everyone! The cool dissolve effect you just saw is exactly what we're going to build in today's video, step by step, from a blank file using Three.js TSL. This kind of effect is very common in games and movies. With TSL, short for Three.js Shading Language, we can create it in a way that's both powerful and intuitive. In this video, we'll go through how to set up the TSL environment and how to combine core nodes like noise and step, just like building with Lego, to create the final animated effect. Ready? Let's get started. Alright, let's start by setting up the outermost application component, our stage. First, we need a canvas to display the 3D content, which is the canvas component. I'll set up the camera first. We give it a camera prop, set its position so it's a bit farther from the origin, and then adjust the FO view, that's the field of view, so the scene looks more comfortable. Next comes the most important step for running TSL. We need to tell the canvas to use the WebGPU renderer instead of the default WebGL. We do this through the GL prop. This prop takes an async function. Inside, we create an instance of WebGPU renderer, call and await its init method, and then return it. That switches the render over successfully. To make the canvas cover the full screen, we add a style prop setting both width and height to 100 VH. Personally, I like using a dark background, like $222, so the glowing effects later will stand out more. Okay, the basic stage is ready, but if we put an object in now, it'll be completely dark. That's because the mesh standard node material we'll use later needs lighting, so let's add lights in advance. We add an ambient light to give the whole scene some base brightness, and a directional light shining from one direction to create contrast between light and shadow on the model. Finally, to make it easier during development to freely rotate and zoom in on our model with the mouse, we'll add one more super useful helper component from the Dre library, Orbit Controls. Now our stage is fully set up. Now let's create the component that actually implements the dissolve effect. We'll call it disintegration effect. To keep the code clean, we'll define it as a separate component. This component will return a torus knot model. Now comes the core part, creating a TSL-powered material for it. For performance reasons, to avoid recreating a heavy material on every render, we'll wrap the material setup inside a useMemo hook. Inside useMemo, we create a mesh standard node material. Notice that I'm setting two critical properties right away. Transparent equals true to enable transparency, and alpha test equals 0.5 to give us a clean, sharp dissolve edge instead of a blurry, semi-transparent one. Next, we apply this material to our torus node. That's it. Our effect component is ready. Now, back in our main component, TSL disintegration, we render it. Then, we check if our orange torus knot is showing up correctly. Perfect! The component is now properly set up and connected. Let's move on and start writing the TSL node logic. Step 1. Generate a noise pattern. We use the mx_noise_float node to produce random values between 0 and 1. It needs to know where on the model to generate, so we pass in the UV node, which gives the surface coordinates. .mol 5.0 adjusts the density of the noise pattern. Step 2. Create a dynamic threshold. We need a value oscillating between 0 and 1 to control the dissolve process. For this, we use the oscTriangle node. It takes time, a continuously increasing value, and converts it into the back and forth animation we need. .mul of 0.2 controls the animation speed. The smaller the value, the slower the animation. Step 3. Cut with the step function. This is the key part. The step function compares the noise value with the dynamic threshold. If the noise value is greater than the threshold, step outputs 1, opaque. Otherwise, it outputs 0, transparent. This gives us a clean black and white mask. Final step. Connect the nodes. We take the result, final alpha, and hook it into the material's opacity node property. That completes our material logic. Look, it's moving. We did it. A fully TSL-driven high-performance dissolve effect is complete. This effect looks awesome, but the real power of TSL is that it gives us a very intuitive way to debug and tweak it. Let's play with some of these parameters and see what they control. First is the animation speed. It's controlled by the 0.2 inside time.mul times 0.2. If we make it smaller, say 0.1, you can see the dissolve and reassemble cycle becomes twice as slow. The smaller the number, the slower the animation. The scale of the noise, that's controlled by the 5.0 inside uv.mul times 5.0. This number is actually the zoom level of the noise pattern. If we make it much smaller, like 1.0, and if we make it much larger, say 10.0, the effect changes completely. Now it looks like the object is breaking apart into very fine pieces. By adjusting this value, you can control the texture of the dissolve. Alright, let's set the speed back to a moderate value, like 0.15. The best part is that this material is completely decoupled from the geometry. What does that mean? It means we can apply the effect to any mesh. For example, let's replace the torus knot with a simple box. A box has different arcs than a torus knot. In fact, a default box doesn't need any arcs, so we just remove them. Look, the same dissolve effect now applies perfectly to a cube. On the cube, maybe a noise scale of 10.0 is too much, so let's bring it down to 2.0. Yes, that looks much better. You can freely adjust these parameters depending on the model to get exactly the look you want. Let's do a quick recap. The whole process is like building with Lego. We use the MX Noise float node to create the base dissolve pattern. Then we used oscTriangle with time to generate a dynamically changing threshold. Finally, we used a step node to compare the pattern with the threshold, deciding which parts stay visible and which parts disappear. That's the beauty of shader programming. Just a few simple nodes can combine into endless visual possibilities. I hope this video was helpful for you. If it was, please make sure to like and subscribe. It's the biggest support for me to keep creating. Thanks for watching, and I'll see you in the next video.